It's important to note that datetime is a structure, not a class, and from your perspective, all you need to know is that you don't need to use the new keyword unless you want to call one of the constructors of the datetime class. The values range from 1101, that is January 1st of 01 at midnight, up to just before midnight on 12/31/9999. If you're working on dates outside that range, you'll have to think of something else. Datetime values are measured in ticks. That's a 100 nanosecond unit, so it's pretty granular. That is the measurement of dates and times in the .NET Framework. Now, it's important to note that the date-time value in the .NET Framework represents a single instant, not an elapsed time. If you want to keep track of elapsed times, you need to use the time span structure instead. Also note that date-time calculations don't modify the value that's in the date-time. You'll return a new date-time or time span value when you perform a calculation on a date-time structure. Now, the datetime constructors aren't really required unless you want to create a new datetime value already filled in. You don't need to instantiate it and then give it a value because the moment you declare it, it exists in memory. That's what a structure does. You can specify in the constructor a number of ticks. That would be the number of ticks since January 1st, 01, a year, month, and a day, a year, month, day, hour, minute, second, and a couple of other ways you can specify the constructor as well. So you can declare an instance of the date-time structure and in the constructor pass information so that the structure contains the date-time value you want immediately. What if you want to get text, say, from a text box into a date-time value? You can use the parse method of the date-time structure. Now, of course, if you pass in invalid data, you'll have a problem, and you'll throw an exception. A better way to do it, then, is to use the try-parse method instead. Try-parse attempts to parse text into the datetime value and returns a Boolean indicating success. It never throws an exception. Let's try some examples that work with datetime values. I'll click the Dates and Times button on our main switchboard form, and this brings up this form that allows us to investigate properties and methods of the date-time type. Well, certainly it's interesting and we'll investigate each of these, but the most important part is how do we get this date-time value from this text box into a real date-time value? To do that, we click the Calculate button, but let's look at the code that executes. Here you see in the code, we first declare a date-time value, and I gave it some value, so it has something in it. Now, I'll call the try-parse method of the date-time type, given the text we'd like to parse, and an out variable, dt. So it knows it's sending a value out from this method call. It either succeeds or it fails. If it succeeds, it's because we entered a value that is a valid date-time type, and then we'll use a bunch of properties and methods of the date-time type to display information on the form. If it fails, we display a message box indicating that it failed. But it all boils down to this call to the try-parse method, which is available on multiple classes, to convert the text into a real date-time type. I'll run the project again, and this time we'll click Dates and Times and see how it all works. First of all, even before I click Calculate, you can see here some properties of the date-time type. We have today, UTC now, which is the current time in UTC format, that is at the Greenwich mean. Notice that today assumes a 0 for the time. Gets the date right, but nothing for the time. UTC now is the correct time in Greenwich coordinates, given the current time here. The min value and max value show us the min and max values for the date-time structure. If I click Calculate, here you'll see we've calculated a bunch of things. For example, datetime.date gives me just the date portion of this date. Here's the day, that is the day of the month, the day of the week, the day of the year, the hour corresponding to my value up here, the millisecond, the minute, the month, and the second. Those all seem reasonable. Here's the number of ticks corresponding to this date. That's the number of ticks since January 1st of the year 01. It's the time of day here, which is in military time, and the year tells us, well, the year portion of the date that's selected right up here. Let's look at some of the conversion methods. Here we can convert this date to a file time. This is a special structure that files need to keep track of their own time, and we've converted it to that format. Here's the local time, which takes into account the Greenwich Mean Time and gives us, as if this was Greenwich Mean Time, it subtracts or adds the necessary offset to give us the local time if this was Greenwich Mean Time. We can convert it to a long date string, to a long time string, to an OA date. Well, this is picky because automation applications like Excel or Word expect dates to be stored in a certain format, actually VB6 as well. Any VBA-related language expects dates to be stored a certain way. The to_OA date method converts the local date here to that format. This turns out to be the number of days since December 30th, 1899. I believe that's the date. And this is the fraction of a day that the time here represents. We can convert it to a short date string, to a short time string, just to a string, and to universal time, again, converts this back to Greenwich Mean Time as a string. We can perform calculations. Here, for example, we can add a number of days to this date. Add a number of hours, puts us 3 hours ahead. A number of milliseconds puts us 3 milliseconds ahead. Add minutes and so on. We can add negative days. Come here and calculate. That puts us back 3 days in the past. The same thing for seconds, ticks, and years. There are methods of the date-time structure. For example, there's a days in month method. You give it a year and a month, and it will return back for you the number of days in that month. There's an is leap year method that returns whether or not a year is a leap year. And there's the from OA date method, which given an object automation date like this one, returns it back into a standard .NET date. Finally, I have some methods here that allow me to do some calculations based on date times. There's a first day in month, last day in month, and next anniversary method. First day in the month returns the first date in the month you select here, May 1st. Here, the last day in the month. And finally, given this date, what is the next anniversary of that date? We'll look at the source code for those now. Let's put all this away. I'll open the date time info class, which has the procedures we need to look at. And you'll see here a couple of overloads for first day and month. This one takes in a date time value. This one takes an individual year and month. So use either one you like. How does it work? Well, given a date time value, we'll just create a new date time using the year and the month of the date time you specify, but one for the day of the month. That gives us the first day of the month you specify. For last day in the month, given a date time value, we need to calculate the first day in the month, just as we previously did, and now add a certain number of days to it. How many days do we add? We add the days in the month for the year and month value. Given that information, subtract 1, so we'll end up on the last day of the month. And that's the return value. So that's pretty easy too. Next anniversary is a lot more complicated because of the dreaded leap day problem. We're going to calculate the anniversary in the current year and also store away the current year. Let's get that information first. Given the current year and the date you've specified, if the month is 2 and the date is 29, means if it's leap day, if the person was born on or was married on or whatever, on leap day, you need to find out if the current year is a leap year. We do that by passing int year, that's our current year, into the isLeapYear method. If the current year is a leap year, then the date within the current year is February 29th. If the current year isn't a leap year, then the anniversary date within the current year is March 1st. Now we need to see if the anniversary has passed in this year already. Imagine the anniversary date was February 29th, and today's date is June 1st. If the current date we're looking for, that is our anniversary date, is less than today's date, the anniversary has already passed. In that case, we need to add a year. But how do we add a year? Well, if next year is a leap year, then our new return value is next year on February 29th. If next year isn't a leap year, then next year's anniversary will be March 1st in the following year. All that code to deal with one date, that is February 29th. On the other hand, if it's not February 29th, it's a lot easier. We take the current year, the month and the day of the anniversary, and get the value in the current year. So if the anniversary date in the current year has already passed, we need to bump ahead to the next year. Anniversary has already passed, that means the next anniversary is next year. If the anniversary hasn't passed yet in this year, we don't run this line of code. Say the anniversary date is July 1st and today's date is June 1st. In that case, the current date in the current year is July 1st. We're currently on June 1st. This expression won't be true. We won't add a year, and we'll return July 1st in the current year as the next anniversary date. But imagine that the anniversary date is July 1st, and today's date is August 1st. This is less than today's date, which means we've already passed the anniversary date this year. We need to add 1 year to it, so we'll now get the anniversary date in the next year, and we'll return that anniversary date. If it wasn't for the leap day problem, this is all the code we'd have. Unfortunately, for leap day, we have to do all this work to see if this year's a leap day, if next year's a leap day, and on and so on. You may find an easier way to do this. This is the code I wrote. If you find an easier version, I'd sure like to know about it. You may find that you need to deal with localized date information. System.globalization.datetime.format.info provides information you'll need about local date and time formats. Month names, date separators, and much more are available. Now, digging deep into all the information, because some calendars don't use the same number of days per month, the same number of months per year, or even the same year number that we use in the United States. So I can't dig into that here. But you might want to just write applications that display dates correctly outside your local country. In that case, you'll need to investigate the System.globalization.datetime.format.info class. I have an example that shows off at least formatting dates in a different locale. I'll show the form. You can investigate the code if you're interested. On the demonstration form, I'll click Date Time Format Info, which displays this form. You can see that we can select from any of the languages. I pulled this by iterating through all the locales installed in the .NET runtime. We can choose, for example, Arabic or Spanish. And here I then iterate through all the calendar month names for that language and display them within the output window. Let's pick an interesting one. Didn't display that one correctly, apparently. Here's Greenlandic from Greenland, and so on. It's interesting and fun to see these languages here, but the code in this form, which I won't delve into now because most people won't need this. It's nice to know that it exists, and if you need this functionality, you can use this form as a starting place to investigate formatted info for different locales. If you want to handle elapsed time, you need the time span type. And just like the date time type, this is a value type, that is a structure. You don't need to create a new instance unless you want to create a new one all filled in with a specific value. A time span represents a number of ticks. Under the covers, that's really what it is, a number of ticks. You can represent a time span value using this format, that is plus or minus, D, that's number of days, .hh, that's hours, : mm, that's minutes, (ss), that's seconds, .ff, that's the fractional part of the seconds. A day is the largest unit measured by time span. For long periods, you'll just have a large number of days. If you have a time span that measures 50 years, for example, that'll be just a large number of days measured in that time span. There are a number of different ways to create time span values. You can, for example, subtract two date time values, which returns a time span. The time span has a duration property, which returns the absolute value of its contents. If you're subtracting two date time values, most likely all you really care about is the difference between the two, not a negative or a positive value. So you could use the time span's duration property to return that absolute value. You can use a constructor of the time span type. You can supply ticks, or you can supply hours, minutes, seconds, or others in the constructor for your time span instance. You can call the parse method, and again, I don't recommend parse because it raises an exception if you supply an invalid input value, or the try parse method, which returns true or false, depending on its success. You can also use methods like from, days, from hours, and so on to retrieve a time span value. Let's try an example which shows off using the time span type. I'll bring up the time span demonstration form, and this one, just like the previous example you saw, attempts to use the try parse method to parse the values I've specified here and do calculations based on them. So let me call the try parse method of each and see what happens. Here, for example, we'll look at the days associated with this value, and it's 0. The hours is 9. It's actually the difference between these two things that I'm calculating here. There's 9 hours between them, 0 milliseconds, 11 minutes. There's 5 seconds difference. Here's the number of ticks between them, the total number of days, the total hours, the total milliseconds, total minutes, and total seconds represented by the difference between these values. How about fields? Well, the time span type provides a number of values, that is, corresponding field values. The maximum value is this many days, hours, minutes, seconds, and partial seconds, and the minimum value is this many days. It's a negative value. Ticks per day is a built-in constant, ticks per hour, ticks per millisecond, ticks per minute, ticks per second, and there is a 0 time span, so you can tell if a value is 0 or not by comparing to it. These are values that will help you work with the time span type. There are methods as well. We can say from days. So here's 13.456 days is a time span with this value. 47.6 hours is this time span. This many milliseconds is this time span. From minutes, 128 minutes, well, it's clearly 2 hours and 8 minutes. From seconds, 289 seconds is 4 minutes, 49 seconds. And from ticks gives us a time span value like this one. Now, these examples all use ending times and start times here. You can also try this form just by parsing an existing time span. Let's calculate here. And this one, for example, if we've parsed it, is 3 days, 14 hours, 55 minutes, 26 seconds, and 270 milliseconds. So you can either, for your time span constructor, subtract two date time values or parse an existing time span value. Either way, you end up retrieving information about a time span, which is either the difference between a date time and another date time, or just a single time span parsed out. If you're interested, you can look at the code, but each line of code just sets up a single value on this form by calling one of the methods, fields, or properties of the time span type. The time span type is great for storing elapsed time, but how do you measure elapsed time in real time in your applications? The system.diagnostics.stopwatch class makes this easy. It's a really simple class. It just has a few instance methods, start, stop, and reset. And it also has a shared or static start new method which returns a new instance. It has a few maintenance members like elapsed, elapsed milliseconds, elapsed ticks, and is running, so you can tell if the stopwatch is running or not. Well, we have an example form that demonstrates the stopwatch class and shows how you can use it to measure elapsed time. Let's look at this form to see how you can use it to retrieve a time span that measures real elapsed time. I'll run the sample form, and here I'll click Me first, and right now the stopwatch is running. When I click this, we see the elapsed time as a time span. It was almost 4 seconds there. Well, let's see how this form is doing its work. So what's in this form? First of all, we have a private variable of type stopwatch named SW. And here's our first button click. What does it do? It sets up the user interface, but the main part of this is calling the start new method of the stopwatch class. That's a static method that hands back a stopwatch instance. When I click the second button, I just display sw.elapsed.toString. That gives me the time span associated with that current stopwatch. I reset it as well, so I can go back and click the first button again to restart the stopwatch. That really is it. That's all the code I need to measure elapsed time. No loops, no timers, just the stopwatch class does the work we need. If you're interested, you can investigate some of the other properties of the stopwatch class in addition. But for this simple demo, that's all we needed.